Okay, now we are recording. These are the instructions for GIS Assignment 3, group project, GIS applications and the assessment of urban population vulnerability to the coronavirus. So you might ask, well, why are we doing this? Well, geographic information systems has become a very important tool in the mitigation of this pandemic. So I'm going to show you a couple of coronavirus maps. This is one of my favorite ones. This is the, as a matter of fact, I'm going to put the link to this map in the chat, just FYI. Let's see, can I get to the chat this way? Chat, oops. So I'm going to put the link to this map in the chat just for your edification. So this is the CDAC COVID viewer, and this is a really interesting map. So when we zoom in, notice it goes from the state level to the county level. And so we can look at the total cases of COVID-19. And so notice if we click on Nashville, we get a really nice infographic showing how the cases were really up in July. We had a spike, and we've been doing a good job at getting them down. You can see the total cases per person in the last, per 100,000 people in this last 7 days. Total cases per 1,000 people or per 25 people in the last 7 days. In turn, now we can look at mortality, the number of deaths in the past 7 days, and so on and so forth. And so we can go around to any number of cities. Let's look at Huntsville, Alabama, and environs, Madison County, and we can see the rates there. So again, what's most important are the rates, not necessarily the numbers. So you can get a relative idea of how one place compares to the other. This is a really neat tool. And so decision makers are using this tool in order to determine, how different locations are doing. Notice that if we let's look at the 7-day moving average, we might see some interesting numbers. So notice, looks like Memphis is getting better in terms of number of cases per week, going down. Shelby County, Tennessee, Memphis. And so we can look at a variety of other demographic data in terms of COVID-19. So are we using these data simply to keep track of what's happening? No, it's larger than that. These data are being used in decision-making. Here's another map. This is the National Geographic COVID map. I'll also put the link to that map in the chat for your research and edification purposes. And so if you notice here, scroll down to the map, you have, now here we have weekly changes in terms of cases. And so we can focus in on specific areas. So here's Davidson County again. Now on this map, Davidson County, interestingly enough, appears to be doing better than Memphis in terms of cases within the past week. And so again, we can use these maps. As you can see, there are certain parts of the country where things aren't going as well as they are here. If you notice in the, looks like Florida is doing much better. For you all planning to travel, just to stay out of Glades County isn't doing very well, and neither is Okeechobee, Florida. Pennsylvania, that's Alabama. Let's see, let's see, Walton, Okaloosa, Santa Rosa. Where's this? Trying to get this Escambia County. There's Escambia County. That's essentially Pensacola. They seem to be doing better. So mapping and geographic information systems are being used as a prominent strategy for fighting this pandemic. And it's largely because we need to make decisions in terms of the allocation of resources. It would be great if we had an unlimited supply of PPE. It would be great if we had an unlimited supply of PPE is personal protective equipment, such as masks, face shields, et cetera, et cetera. It would be great if we had an unlimited supply of test kits. It would be great if we had an unlimited supply of ventilators and all the things that we need to fight this virus, but we know that we don't have unlimited supplies of anything. So we have to be judicious in deciding what cities, what communities get what equipment. We also, so in order to determine that, the main issue is population vulnerability. You know, what are the characteristics of a population that make it more vulnerable to this virus? Some of these characteristics we already know. We're going to go through some of them as we work through this assignment. So here's the assignment. Type your group number there. If you want, you can put the names of people in your group on the assignment. I would, just in case. And so then we move on. Most of you all already have your own public account for ArcGIS Online from the first assignment. You're going to find a lot of similarities between this assignment and GIS Assignment 2. So this should not be as challenging for you as that one was, perhaps. For instance, you should already have your public account for ArcGIS Online. If you do not, because remember the last time you only needed to have one person in each group post the map. If I were you, you know, I'm from Baltimore, we say TNO, trust no one. DTA, don't trust anybody. You know, I would have my own map on my own account. First of all, that's to protect you in case a person disappears from the class. Second of all, if and when you are applying for an internship, job, fellowship, research position, et cetera, and someone asks you if you've ever had experience using geographic information systems, you can point them to the link to your map in your digital portfolio. So all of you all should have a digital portfolio along with your resume that actually shows what it is you've done during this time that you're in college graphically. That's called data visualization. When you take data and visualize it and show it to people, then people might see what you can do and it can open doors. So you should have your own account. Okay, so moving right along, you've been assigned cities, 4 cities, 5 cities. As a group, just rank them. Just based upon conjecture. I don't want you to really get into any research at this point. Just rank them. What city do you think will have the most vulnerability to COVID based upon what you know about COVID, just based upon your anecdotal information about COVID-19, just rank the cities. You don't go looking online, just based upon what you know, just boom, 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 rank the cities. It should take 2 minutes right here, okay? Just based upon conjecture, whatever you believe makes a city more vulnerable. Next, we're going to get into the research, okay? After you've ranked your cities the first time, we're going to get into the research. I will provide you a spreadsheet, just like I provided you a spreadsheet last time. And so the spreadsheet obviously is not there yet because I had to figure out how many groups you have, but let's see, I'm going to find the spreadsheet source and I'm going to demonstrate for you how we're going to walk through this project. So let's see. So here is a here's a spreadsheet that I already started. This is just a demonstration. So I already started this spreadsheet. This is the working demonstration spreadsheet. So I'm just going to walk through it for you just to demonstrate. So each of you will have a spreadsheet, not each group will have a spreadsheet. So just like last time, you'll enter the data, you can just break it up. Each person can enter his or her own data, just teamwork makes the dream work. So let's say I'm going to add to this sheet, Baltimore, Maryland, and some of this will be review for some of you this will be new. Okay, so the first thing that we'll enter into the spreadsheet, so we're going to fill out these fields just like last time. City name, city state, just did that. Okay, city latitude and longitude, we'll go to Google Maps again. Here, Google Maps, I picked Baltimore, Maryland, just like I did last time, except this is different. Baltimore, Maryland, boom, zoom into your city. Just find any random place, maybe some place that you can identify. So I'm going to use the Baltimore Zoo as my landmark. Drop that pin, and then you'll get the lat long. I'm going to write it down. I'm going to take a chance on trying to copy and paste because it might blow up. So that's latitude 39.325, 868 degrees north. Longitude minus 76.648263 west. Go back to the spreadsheet, pop that in. So it's 39 point, remember, don't round off these numbers, 325,868. Longitude minus 76.648,263. Boom. All right, so again, population and population density. We'll go to the census site. So as you can see, the next 1, 2, 3, 4, 5, 6, 7 fields you'll get from the census site, just like last time. So just to review, here, and we'll go here, census.gov. Then remember, from the census site, we want to go to Explore Data, then Explore Data Main, and then click on Explore Data Main. Scroll down to Quick Facts, click on Quick Facts, and then type in your city here. I'm recording this, so you will have it as soon as I can get it together. Here's Baltimore, Maryland. There's Baltimore, Maryland's population for 2019, the latest data available. Now this one I'm pretty confident I can copy and paste without any problem. Just go here, population, and I'll go here, right click, paste special, values only, so you don't bring that code into the sheet. Boom. Okay, population density, which is another pertinent factor in COVID-19 mitigation. How many people there are per square mile. So you know that if places are more densely populated, there's a greater chance of transmission. So that's Baltimore's population per square mile. You have to scroll all the way to the bottom. It's 7,671.5 people per square mile. Here, paste, values, boom. Okay. Now I'll allow, so just wanted to demonstrate 2 of those. But of course, the rest of the fields, not the rest of them, but these next few fields, population over 65, percent population over 65, percent African-American, percent Latinx, percent in poverty in your city, you can get all that from the census site, okay? All right, so next we are at field L. the city county social vulnerability index, you will go to a map. And I'm going to show you here. Click, copy, bring it into another, put it here, open it up. So what is the social vulnerability index? Notice that this is a map that is provided by the Centers for Disease Control. The social vulnerability index is a scoring system that gives us the relative vulnerability of human populations to any hazard. It could be a hurricane, it can be a pandemic, it can be a tornado, it can be what earthquake. And so we use this social vulnerability index in order to plan for disasters, in order to plan for large problems, so that again, we can prioritize where to send resources. We want to send resources to places where they are needed most. And so we need to know where populations are most vulnerable to whatever. What are indicators of vulnerability? Well, for coronavirus, we know that age is a indicator of vulnerability. People over the age of 65 have a much, much, much higher mortality rate to this disease than other age groups. We know that race is another indicator of vulnerability to coronavirus. We know that African Americans have a significantly higher infection and mortality rate from this disease. So race is a factor in terms of this coronavirus. Also, economic status. If you are lower income and you have probably less easy access to healthcare, that is going to put you in a vulnerable position. If you are in a situation where your employment status places you in contact with people at a greater rate, in other words, you cannot work from home. You cannot work in banquet services at a hotel from home. You can't ring up people on a cash register at Kroger or Walmart from home. You have to be there. You have to be breathing in other people's air. That puts you at greater vulnerability. So all these various factors contribute to the vulnerability of different populations. However, if we were to lay out all those factors qualitatively, it would be almost impossible for any human brain to rank places based upon their vulnerability with the raw data. So what is done when we create an index is the data are normalized based upon a scoring system, say from 0 to 100, where 100 is the place that has the highest number for that specific indicator, and 0 would have the lowest. So for instance, just for example, if a place, let's say if Baltimore, Maryland has 25% of its population age 65 and older, and if Baltimore, if that indicator for Baltimore is the highest of any city in the United States in our database, that would get a score of 100. On the other hand, if Durham, North Carolina has 12.5% of its population age 65 years of age and older, then of course 12.5 is 50% of 25. So therefore, Durham, North Carolina would get a score of 50. Okay, so that would be lower. So let's look at Baltimore's social vulnerability index, which is again is a combination or a accumulation of all these various factors. You can already see, based upon the legend, that Baltimore's social vulnerability index is in the higher range, just based upon looking at the color ramp here. And so if we click on Baltimore, then we can get the data Wow. So the highest social vulnerability score would be 1, right? Baltimore's overall social vulnerability index is 0.8364. So that is significantly high, right? For a variety of reasons. If you look at poverty, if you look at age, if you look at whatever. Now, remember, this SOVI score is not specifically based on COVID-19. This is a score that indicates how vulnerable Baltimore's population is to anything, right? And so we'll take this score and we'll enter that into our database. So here's the SOVI index. Boom, right click, paste special, values only, boom. And now we have Baltimore's SOVI added. Okay, so moving along to the next variable, you probably already knew this, percent city population of adults with asthma. So we know that COVID-19 attacks the lungs. So obviously people who are asthmatic are at much greater risk of being negatively impacted by COVID-19. So let's go to another map or another data set. This is the, again, Centers for Disease Control. Centers for Disease Control, 500 Cities Project. So we can go in here and we'll just follow the instructions. Here, go to the map, select location type by city and state. That's here, location type here, that's city. And so we'll go, Baltimore's in Maryland. And we'll go down to Maryland, 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 Michigan, almost there. There's Baltimore. Click on Baltimore, hit the go button, and it'll take us to this data table. And here, current asthma amongst adults 18 years and older. Notice that for the nation, the average percent of adults with asthma is about 9. For Baltimore, it's 11.3%. So clearly, we have some issues in Baltimore. And if you look at it in terms, so there's 11.3%. So we know Baltimore is looking, ooh, man. Wow. So remember, no percent sign in this column, just the number. Next, unemployment. So remember, this pandemic is impacting us not just in terms of our health, but also our economic status. So we'll go to another map, the ArcGIS Living Atlas. Go here, 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 boom, 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 boom. Go to the ArcGIS Living Atlas, follow our instructions. See, type unemployment into the search bar. So we'll type unemployment. And so we know that a lot of people have lost their jobs, probably permanently, during this pandemic. That is a sign of vulnerability. So now it says we want to look for the Bureau of Labor Statistics monthly unemployment map. So here it is, Bureau of Labor Statistics monthly unemployment map. Click there, boom. Click here. And now, of course, we will look for, you can type this in the search bar in case you're not sure where you are. Some of you might not have cities you're familiar with. Baltimore, Maryland, zoom in. There's Baltimore. There's my legend. Wow, this is interesting. That is not what I would expect, but let's check it out. Well, no, wait a minute. So Baltimore, now that's Interesting. Baltimore is not doing too bad in terms of unemployment compared to the national average. Now, you can clearly see that there was a spike, but even with the spike, Baltimore, now 10% unemployment is bad, just in general. When we were going through the recession of 2008, 2009, and unemployment rates went up to 10%, that was considered very bad. But right now, with coronavirus, notice that I think Chicago's unemployment rate is 18.5%. So these are unprecedented times here in terms of human suffering from a variety of problems. Okay, so last but certainly not least, field O, population exposure to particulate matter 2.5. What is particulate matter 2.5? PM 2.5 are very small particles invisible to the human eye that are produced by automobile exhaust, industrial pollutions. There's a lot of particles that just exist in nature. When we breathe these particles in, they adhere to the lungs and make us much more susceptible to COVID-19. So any place that has elevated levels of air pollution in the form of particulate matter is going to be an area where people are going to be at greater risk to COVID-19. So that takes us, so let's see, we'll go back to the Living Atlas here. And in this case, well, let's just start over. Let's go back to Living Atlas here. Click, copy, boom, 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 boom. And I guess next thing I think we're going to type into the search bar particulate matter and hit return. And then we'll get a series of maps. And the map that we want is the one entitled Population and Particulate Matter in the U.S. between 1998 and 2016. So that's looks like it's this map. Click here. Same thing, open up the map. Let's find our way to Baltimore. Baltimore, Maryland, USA, boom. Now you have to be a little bit, let me see, you have to zoom out a little bit until we get either to city. So we're at these small, it's too small. We want to keep zooming out till we get to the county or city level, keep zooming out. They're still giving us these hexane, but it's still, okay, now we are congressional districts, out a little bit more. Counties, so that's close enough. We have to get in here and just hit right there, Baltimore City, Maryland. And what we want to look for is the exposure. So we factor in population, that's 13.82 micrograms per cubic meter, 13.82. So now we have our, at least this isn't, of course, I didn't do the entire spreadsheet for you, but it's most of the data. And so once you filled out your spreadsheet, you go to File, Download, Microsoft Excel, and I'm just going to enable editing, File, Save As. I'm going to save it in GEOG 1010, Fall 2020. This is the demo spreadsheet. So I'm just going to copy over the old one. Yes. Close. Now, of course, per the instructions, I have to save it as a common limit CSV file, save as here. CSV, comma delimited file, save, yes, okay, yes, close it out, save, yes, okay, now it's saved. Now you open up your ArcGIS Online account. Now here, sign in, and then go to the map. Okay, now you're at your map, add layer from file, choose file. Here it is right at the top, open, import layer, okay, and here we go. So your next steps are to, after you create, well, the first step, of course, is just to have the names of your cities, just like you did last time. And here we go, done, legend. Okay, and so now you want to, now this might be a little bit tricky because what I want you to do is when you create these screen captures, I want you to go to print, map with legend, and it may or may not give you what you want exactly. I'm not really going to give you a hard time about this. Let me just see if something works here. Okay, it's taking its time loading. Notice this. I notice it does kind of, it's not really a perfect example. It's not, this just isn't working like I would like it to, because clearly only one of the cities is on the map. But I'm not going to give you a hard time about this. Probably in this case, just to be better servants of mapping, we can still print the screen and include the legend like this and then pop it in. So the first thing you'll do is you'll pop in screenshot displaying your cities, paste. Okay, so there you go. That's your first map, not necessarily your map that you'll analyze. But now we're going to get into our map analyses. And so go back to this content. We want to look at maps that will give us an indication of something that might give us an idea of how susceptible these populations are to COVID-19. So we have looked at, here's asthma. And so if you notice, we have a little bit of an exaggeration here with the symbology. So if you want to change that, go to this little change style, hit that, go to options, click there. Notice you have a range of size from smallest to largest for your symbols. Maybe make that symbol, make it a little bit better so you don't have that extreme difference there. You could make it proportionate, but we're not going to go through all that right now. But at least now you can clearly see, even with the change in the symbology, that Baltimore clearly has a bigger issue with asthma than Los Angeles or Chicago. Not a huge difference, but a difference just the same. So there's a map that you'll use for your analysis. Hit print screen, and you'll go down here. Here's your first figure. Paste map here. Paste. There's your next map, your asthma map. And boom, border, weight, 1, boom. Okay, now with any figure, you're going to give a descriptive title, and you might call it U.S. cities % of adults with asthma. And then of course your map data source, in this case, You can get that right from the instructions. So we got the asthma data from the 500 Cities project. Here, copy down. So with any map that you have in a document, or if it's your master's thesis, or if it's your senior project, you should have the source of any image that you have in a paper. You shouldn't just post or paste a map or a figure anywhere without giving credit to where you got it from. So you will post 5 maps altogether, and with descriptive captions, and then you will analyze your maps. So in the space below, just look at the maps and go through an iterative process of what you see, comparing the relative vulnerability. You might organize it, say, asthma rate. We noticed that Baltimore had a significantly higher asthma percent population asthma than the other 2 cities, blah, 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 blah. This would indicate that that population may be more vulnerable to COVID-19. Your next map might be age. We noticed that city X has a significant high, just like that. Just analyze the data. This is the discussion portion of your paper. You're not drawing any conclusions here. You're just analyzing the data. What do you see on these maps? Okay. And that's what goes into your 500-word essay here. Then after you analyze your maps, you will rank your cities, re-rank your cities based upon your analysis, okay? And then after you re-rank your cities based upon the analysis, you will write a second 750 or more word essay where you will address the following. Is your final city ranking different from your ranking from part 1? From your first ranking? Probably so. What were the variables that influenced the change in your rankings? We thought that it was the asthma, blah, 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 blah. Did collecting and mapping data using GIS give you a better understanding of how COVID-19 risk assessments are conducted? The answer to this question cannot be no. And it's not a one-word answer. It's not yes. Yes, how so? How did it? Now, here's where you can kind of go, not stream of conscious, but you can essentially be expository in your answer here. You know, what do you think? You know, how did this affect you? How did you see? How can you see this better? Right? Did you see anything interesting or unexpected? Did you expect did your first city that you thought was going to be the most vulnerable not turn out that way? Was there something you really didn't expect to see? Describe that. When you look at your cities, what mitigation measures should they put in place? Should they continue to wear masks? Should they open up? Should they begin more testing? What do you think based upon what you see? Then finally, what did you learn? What did you find most interesting? And then you will upload this entire document to the Dropbox along with your CSV and Excel tables. Now, each group must prepare a map demonstration based upon your findings. We'll probably do a rough run through next week. But what I'm thinking is that what we usually do every year is we participate in GIS Day, which is an international celebration of geographic information systems. And we usually pair up with another university or sometimes a high school. I'm thinking that we'll pair up with Morgan State University in Baltimore this year. So you all will present your map. The students from Morgan will present their map. GIS Day is on a Wednesday, but we might just do yours on the day during class. And so that you will demonstrate to the world your skills in geographic information systems. And so you might think, oh, I don't want to do that. I don't want to be seen. I'm going to be embarrassed. Look, we've done this and had students get internship offers on the spot. immediately afterwards. We've had students get job offers on the spot immediately after being seen. So don't be afraid to display your talents. There are people out there looking for you, and we want our students to be placed in positions of success, and this is the way to do it. So there'll be two things. I'm going to create spreadsheets for each group sometime today. So just wait for that. Each group will have its own spreadsheet. I'm going to post those in the Dropbox probably immediately after this class. I am now going to stop the recording. The recording of these instructions will be posted to YouTube and made available to you as soon as possible.